Order picking is the process of finding and picking items along a given path inside of a warehouse. Essentially, when you order multiple things on Amazon, a worker in their warehouse follows a given path to find their items for packing. This process accounts for up to 55% of the warehouse's total operational costs. As such, there is an economic need for heads-up display solutions to make this process more efficient. So our goal is to first design a Google Glass-based system that can provide real-time indoor navigation and further conduct a pilot user study to compare two different navigation methods, the live egocentric navigation and static exocentric navigation. The project's prototype has two main components, the Glass app for the end user and a tablet controller for location and rotation mapping. For the Glass app, there are two main views, the navigation screen and book info. While the worker is approaching the right bookcase, they see a top-down navigational map which adjusts its orientation based on a rotation. Once they reach the right bookshelf, they can change the views by swiping on glass to see additional information like author and shelf number. Because indoor localization is difficult to implement, we decided on a controller. The tablet is used to control how the map view is displayed on Google Glass, and we pair the two via Bluetooth. Let's take a closer look of how we implemented navigation. We can break down navigation into location and rotation. For the tablet controller, location is updated by swiping along the map view on the Bluetooth control panel portion of the tablet, while rotation is done by swiping along the joystick. Let's combine everything together for a first-person perspective. Note that the heads-up display is in the upper right-hand corner. For Project 1, we implemented navigation through a simple row of 4 bookcases. In Project 2, we expanded our navigation to the entire second floor at TSRB with 20 locations instead of the specific book numbers. We chose this new layout for two primary reasons. One, to focus closely mimic the large scale of real warehouses, and two, to focus more on navigation aspect of Google Glass than the actual picking. Our main focus is being performance and accuracy. We have two conditions. One, having a static map displayed on glass, and two, having a live navigation map also displayed in glass. For each user in the pilot study, we split 10 paths each with 10 randomized locations into two sets of 5, one set for testing and one set for training. We then randomized the order of the 5 paths of testing and training. For each of the conditions within the same testing/training, we retained the same 5 paths but randomized the order they come in. Results were recorded based on the duration of the entire path of the 10 locations, duration of each single picking route, and accuracy of the picking. To conduct the pilot study and to keep track of appropriate metrics, we had a pair of assistants follow the user. One was controlling the tablet view portion during the live navigation condition, and another was timing the path and keeping track of errors. Let's combine everything together for a first-person perspective during our pilot study. Note that the heads-up display is in the upper corner. The result of our pilot study showed a promising trend that the live egocentric navigation could bring higher performance and better user experience to the user, as well as providing crucial insights on how to conduct a future formal user study with multiple users. And to better answer the question whether knowing the location related to their surroundings could decrease order picking time or increase accuracy in low-density picking environments.